So, in the world of cybersecurity, you're always fighting a battle on two fronts, catching the bad guys you already know about and trying to spot the brand new ones you've never seen before. Today, we're diving into this fundamental challenge that every network security system have to deal with. And we'll look at the really smart hybrid solution that's changing the game by basically giving us the best of both worlds. Let's break down how it all works.
All right, so here's our game plan. We're going to tackle this in 5 main parts. First, we'll dig into what the core detection dilemma really is. Then, we'll look at the 2 classic ways of doing things, signature versus anomaly detection. After that, we'll see how the modern hybrid architecture cleverly combines them. Then, we get to the really cool part, how machine learning supercharges the whole system. And finally, we'll wrap up by looking at the challenges that are still out there.
For a long time, security systems were stuck with this really tough choice, a core dilemma, you could say. It was a trade-off between 2 very different ways of thinking. You could either be super precise, or you could be really flexible. But getting both at the same time? Yeah, that was the tricky part.
Okay, to really get a handle on this, let's use an analogy. Imagine these 2 classic methods are like 2 different security guards. Both are protecting the same fortress, right? Their goal is the same, keep the bad guys out. But how they do their job? Well, that's where things get interesting.
All right, so guard number 1, this is our signature-based detection. Just picture a gatekeeper, and they've got this big book of wanted posters. Their whole job is to look for faces they recognize, the known threats. And they're great at it, super precise. If a known bad guy shows up, bam, they're stopped, no question. But here's the massive weakness. If a brand new attacker comes along, someone whose face isn't in that book, whoosh, they're completely invisible to this guard. So how does this actually work? Well, it's basically high-speed pattern matching. Think of it like a digital fingerprint scanner. The big plus, almost 0 false alarms for attacks it already knows. But the constraint, well, it's a huge one. That database of wanted posters has to be updated constantly. If a new threat pops up, this guard is effectively useless until they get the new memo. It's always playing catch-up. Now let's talk about the second guard. This one's completely different. This is our anomaly-based detection. This guard threw away the book of wanted posters. Instead, they just walk around inside the fortress watching how everyone behaves. They're on the lookout for anything that seems weird or out of place. You know, that gut feeling that something just isn't right. And this really gets to the heart of that trade-off we mentioned. Its whole method is to flag anything that strays from what's considered normal behavior. This is what makes it so powerful. It can actually spot brand new, 0-day attacks that nobody has ever seen before. But, and this is a big but, the downside is that it can be way too sensitive. It might sound the alarm for something that's totally harmless, just a little unusual. And when that happens over and over, you get what we call alert fatigue. You just start ignoring the alarm.
Okay, so what do? You've got one guard who's super strict but can't see anything new, and another guard who can see everything new but is kind of paranoid. The solution, it turns out, wasn't to pick one. It was to make them a team. And that's where the hybrid approach comes in, trying to get the best of both worlds.
And this is how that team works. It's a pipeline. First, all the traffic coming in has to pass by our gatekeeper. That's the signature layer. This guard does a quick scan for all the usual suspects, the known bad guys. If it finds one, it's blocked. Right there. Done. Now all the traffic that's left over, the unknown stuff, gets sent on to our second guard, the anomaly layer. This is where the deep behavioral analysis happens. You see how smart this is? The first guard handles all the low-hanging fruit, so the second, more specialized guard and focus all its attention on what's really suspicious.
But wait, the story doesn't end there. The system got even smarter. The real game changer happened when a whole new layer of intelligence was added right on top of this team of guards. And that, of course, is machine learning.
So if our 2 guards are down on the ground, doing their jobs, think of machine learning as the spy master up in the tower, watching everything. The spy master isn't just following a rule book. It's learning. It's adapting. It's seeing the bigger picture. It makes the entire security operation way smarter than the 2 guards could ever be on their own.
So what does this spy master actually do? Well, it basically supercharges the whole system. It automates the process of finding new attack patterns, and it's constantly updating its own defenses. It figures out what data is most important to watch, it labels traffic as good or bad in a flash, and it uses really advanced methods to spot those weird anomalies. And the most important part, it learns. Every new attack makes it smarter.
Let's take a peek inside the spy master's toolkit. You've got a few different methods here. First is supervised learning. This is like giving the AI a massive photo album of past attacks and saying, memorize these. Then there's unsupervised learning. This is totally different. Here, you just tell the AI, Look at all this normal activity and tell me if you see anything that doesn't fit in. It's fantastic for finding things you weren't even looking for. And then you have the really heavy-duty stuff, deep learning. This can analyze long, complicated chains of events to spot those super sophisticated attacks that happen in multiple stages.
So with all this information, how does the system make the final call? Is this an attack or not? Well, it uses something called hybrid scoring. It's pretty clever. It takes the very certain yes or no from our gatekeeper, the confidence score, and blends it with the this looks suspicious prediction from our AI spy master, the probability score. If that combined score crosses a certain line, then, ding ding ding, we've got an alert. It's the perfect mix of hard evidence and intelligent prediction.
Okay, so this sounds pretty amazing, right? But let's be real, even this super advanced system isn't a magic bullet. No solution is ever perfect, and there's still some pretty big challenges to deal with.
For one thing, the AI is only as smart as the data you train it on. The old saying, garbage in, garbage out, is absolutely true here. And you still have that balancing act, trying not to cry wolf with too many false alarms. Then there's the raw power needed. Just processing all that data in real time for a huge network is incredibly expensive. And maybe the scariest part, attackers know we're using AI, so now they're designing attacks specifically to trick or poison the AI models. It really is a constant, high-stakes arms race.
So what's the big takeaway here? It's that by combining these three things, the precision of our first guard, the flexibility of our second, and the intelligence of our spy master, we end up with a defense that's way, way stronger. This quote really nails it. Machine learning is the bridge that connects those two old-school ways of thinking, creating something totally new and more powerful.
And that really leaves us with one final and kind of chilling question. We're in this technological cat and mouse game, right? But what happens when the mice also get AI? As attackers start using artificial intelligence to build their attacks, the big question is, can our defenses evolve fast enough to keep up?